Hi everyone, welcome to today's session on AWS Cloud Path. My name is Elizabeth and I will be taking you on permissions and setting up autoscaling with AWS CDK. So we'll do a quick recap of last week and take like half of the session to actually dive deeper into policies, permissions, and what it looks like in CDK, like best practices. And then we'll go back to our code to go and finish up what we started. So this is what we have been working on. This is from last week. We are deploying this entire infrastructure with AWS CDK, and this post is the recap of last week. But we stopped last week after setting up networking, deploying EC2 instance, our S3 storage, and then we had load balancing. But we haven't been able to test it or make it work yet because we haven't granted permissions and all these arrows that you see in this page, we haven't actually set them up to work like we want them to, all the directions here. And that's what we're going to be doing today, and also setting up auto scaling instead of a single web server and basically plugging everything together. Okay, as you can see, that's what we have in the next steps: the IAM roles and permissions, and then auto scaling. Now, why are we going to be taking a break to talk on policies and permissions? Everything that we have been building in AWS so far, whether via the console, via CLI, via CDK, everything can be managed in any way we want it to. Like, you can restrict access to the people you want it to have access to, or which services in your AWS account you want to be able to access each other and all. There are different levels to these permissions, or how you can put the firewalls or the restrictions, but some that you would naturally work with, some that you have to master. And policies and permissions are one of the things in AWS that you need to really understand well. You don't need to know every single one. Like, there's a lot of policy types, yes. You may not have to work with some of them, like organizations, SCPs, for instance. It's only if you have like AWS organizations set up with like different accounts and users and all that you really need to be worrying about this. But I'm just going to walk you through the basic ones that you need to start to explore. And if you have already used before, like, open your mind onto how you can modify and make it work better for you, essentially. And that's what we're going to be doing. So for the first 30 minutes, we will be looking at policies and permissions. This page, I'm going to be sharing the links after so you can really go into it, because it's a long read, but you don't need to read every single thing. Like I say, documentations are mainly for reference, yes? So we're going to be looking at this document and also this one in the AWS CDK. You'll see why we're also looking at it in the CDK way, because CDK makes it so much easier to grant access and permissions to all the services that you are working with. So back to this, policies and permissions in AWS IAM service. When we started, we created our AWS account and we created a separate user and gave that user access to do things in our account, and we just logged out of our root account because we don't want to be using our root account to deploy resources or to manage like every like thing that we're doing, like day-to-day activities. That's best practice. By default, if you followed this kind of best practice, creating a separate account from your root account, you would have worked with permissions one way or the other, because you need to have granted that user permission. This is what the AWS IAM service looks like. Oh, I need to log in. I'll just log in and we'll have a look at it, and we keep going from there together. So, okay. This user I have logged in is named Dev. You can see it's an IAM user named Dev. This is not my root account. And this user does not have access to view the cost and usage. So every time I log in here, you see access denied for all these things. But it has access to do everything, including IAM. So I granted it the power user access, and I also granted it the IAM full access. Let's look at it here. So this user is Dev here. You can create multiple users and grant permissions as you want, even though it's one account. And this is the dev account, the dev user. You'll see the permissions here. It has the power user access, which allows it to do everything with every service in AWS except like identity management and then billing access and all. But I also needed it to be doing this IAM access thing, so I added the IAM full access. This is what this policy looks like. We're going to be looking at this, yes, but I wanted to show you what this whole thing looks like. So we have a user here, we have permissions. This user, dev, can be part of multiple groups that I can grant permissions to these groups instead of to a particular user. You could have tags to differentiate. It depends on what you want to use for this user. You can manage tags, add tags to separate. Security credentials. If you've been following us, you should also have security credentials configured, access keys, because we used access keys in our CLI. We used access keys. You should have last access. You see when last the login. Like, this is what an IAM user looks like. This is what an IAM user looks like. We also have roles, which are different from users. But roles also grant access to the AWS environment. Yes. So roles can be assumed by, when we use the word assume in AWS permissions, we mean like you being able to take on that identity of the role. The role grants you access to things. So if you are able to assume that role, like, okay, if I'm assuming this role now, that means I have all the permissions that this role has, and I'm able to do everything that this role can do in this AWS account. So users are able to assume roles in AWS environment. Services are able to assume roles. Like EC2 instance can have like, we call that instance profile, for instance, like instance profile, for instance. That's funny. But yes, like services are able to assume roles in AWS environments. People from other accounts are able to assume roles in your AWS account to be able to do things in your account. Like role basically is kind of this temporary access that it's not you creating a user, but you can treat it as if, oh, okay, this is everything I want this role to be able to do. And then when I want somebody to be able to use this role, I add them to like this trusted, we're going to look at it. Let me give you this example, this web server instance profile. So it's a role for our EC2 instance, our web server EC2 instance that we created. And this is what the instance profile looks like. Anytime you see instance profile in any documentation or any write-up in related to AWS, you're talking about a role that you assign to an EC2 instance. So we call it the instance profile. So the description of this role here is that it allows EC2 instances to call AWS services like CloudWatch and System Manager. That's why this role was created. Let's examine this role. Here we see permissions on this role. This, you see, it has permissions also, like the users. The user that we looked at had permissions. All of them, users, roles, you must define what permissions that you want them to have. And I will explain what these permissions look like later. But for now, I just want to show you, like, this is what the permissions have. Amazon S3 read-only access, Amazon SSM managed instance. These are permissions that are in AWS that we can assign. You can add permissions, and then we go. But here's the beautiful part that I want to point out with roles. You see this this tab here on trusted relationships. With this, you are able to specify which entities can assume this role and under which conditions they can assume this role. Here we see here that only the EC2 instance. You don't need to cram this. I am going to explain how you can build this kind of document when we're looking at the documentation. But here we see that the service that is able to use this role is only an EC2 instance. And that is obvious because we see that there's an allow effect here for the principal EC2 instance, EC2.Amazon AWS. All the services follow this kind of pattern. EC2.Amazon AWS, S3. Like that. So the service here, the principal here is a service, and the action that we are allowing the service to do is to assume the role. So I can have different trusted entities here that can use this role. So I can create a single role and then allow trusted entities from different places to use that single role without having to create separate users for them. Maybe because this the situation does not need them to have their own user. Maybe they only need to do something in my account in one day and they're done with it. I don't need to create a user and then delete the user and all that. I can just have the role there and I can modify the trusted entity to that role. Okay, I allow you to use this role today. Maybe next month I need another company to help me review my account, and then I grant them access to assume that role, and the role just stays there, but I remove or I modify, edit these trusted entities. That's how you are able to, use different identity management solutions, like in this whole IAM thing. Now, we've looked at what roles and users look like. If you look here, you see you can revoke sessions, like the active sessions here. You can decide like, okay, I want everyone that's logged in to log out of my account. I don't want anybody to have access to this. And here we don't have security compared to what we're looking at for a user here. We couldn't add the role to a group. We couldn't create security credentials for that role, like in the way you do it with users. I'm just pointing out these two main ones, yes, roles and users, for you to look at. And then we will now go and look at these policies, like these permission policies, what they really are. You may want to skip this, but I advise you don't. Because even if you say you're not going to be managing users, it's only users working in your account and all that, all the services you are building in AWS, when you understand how the permission policies work, how you can, restrict access or secure a particular service or access to a particular resource, it's doubles or let's say multiplies your the value that you're able to provide or present, like by a lot. Because it's not only about building the solution and having it work, but how secure can you make it? I can deploy all the services and just have everything open to access from anywhere so that everything works. I open it up, everybody from everywhere can access everything in this account and everything is working. But the day an issue goes wrong or something happens with this account, I will see it in my AWS bills, because you don't want everybody to be using the things you have in your account. That's why you shouldn't skip this. Permission policies. The permission policies for roles, users, they look the same. I just want to point that out. Like users and roles, they are different, but it's easy for you to attach permissions to them, or create policies that you want to attach to them in the same way. Because I'm bringing it back here, because they are both like identity-based policies that you're going to be adding to them. Now that brings us to this topic of policy types. I mentioned in the beginning that there's a lot of policy types. You don't need to learn everything, but at least you should know these two: the identity-based policies and the resource-based policies. Now, identity-based policies, you attach them to users, groups, or roles. These are IAM identities. Users, groups, or roles. I said that, you can add a user to a group. Instead of you attaching policies directly to a user, you can attach it to a group. And when you add users to that group, they have all the access, like the permissions that you have given to that group. Yes. Same goes to a role, that you can attach the policy to a role. And when a user assumes a role, they have all the permissions you have attached to that role, temporary for the period that they are using that role. You understand? So that's what an identity-based policy is. Like I said, I'll be sharing this link also in the recap so you can, really dive deep into all the details. If you click this, you'll be able to see in depth into um, identity-based policies, like all the stuff, and then also resource-based policies. But back here to the summary. Resource-based policies, these ones are for AWS resources that you create, like AWS service resources. The most common one is Amazon S3 buckets. Amazon S3 buckets. And this one of role trust policies. I said like, oh, for your IAM roles that you can set the trusts, like trusted identities that can assume that role. That trust policy is an example of a resource-based policy. So these are two ways you can grant or restrict access in your AWS resources. You can grant access based on the user, like Adeotun, that's my name, Ade the girl. Adeotun has the permission to do this and that in this AWS account. If I don't have the permission to do this in this AWS account, if I attempt it, I will get an error. And on the resource, you can place restrictions on who can do what or who can retrieve any data or information from this resource. The most common one is Amazon S3 bucket policy. Like saying, on this S3 bucket, these are the only people that are allowed to do these particular things with these resources. That's how it is. So with Amazon S3 buckets, you'll be able to say, okay, these are people that can do this with the bucket itself, and these are people that can do this with the objects in the bucket. Like you can really, really like put different layers and restrict. You can deny, you can allow. That's what you can do with the resource-based policies. So now, having talked about these two policy types, there's more things you may be interested in checking out, but I would say they are not required to continue. As your solutions or the things you're building get more complex, I'm sure you'll find your way to find the information you need, like because AWS documentation is very, very, very bogus, like it's huge, really well inflated, and there's a lot of community created content like the one that I'm doing right now that explain a lot of things. So now we continue with this. Now the structure of a policy. We have talked of the user, we've talked about the roles, we've talked about the groups. Those are like identities. The policies are the permissions we attach to these identities. What does the structure of the policy look like? I think there should be example here. Let me see. Okay, this is just an example of the difference in identity-based policies and resource-based policies. I'm not sure you can see this, but it's just differentiating like, okay, the identity-based policies are attached to the person and the resource-based policies are attached to the resource, saying who can do what with this resource. But I'm looking for the example of the policy statements. It's not here. Let me see if it's here. Okay, yes, it is here. So this is the example of a policy statement. Remember, it looks exactly like what we were looking at here when we listed this. It's still the same kind of structure. I could also use this one to explain this. So looking at this, you can see that there's like a list here where you can attach the policies to the user, like a list. You can add more permissions. And if I choose to add permissions, I'm able to select like, okay, this is console access, like maybe I want to put it in a user group and all. But I'm talking about attaching the policies directly. When I try to attach a policy directly, I see a lot of policies that are already created by AWS. So if you know what you want to grant access to, you can easily search it here. Instead of trying to write it all the way by yourself, you can search it here and you would use it in CDK like that. You can also write your policies by yourself, like just for granular access, like to use the like these permissions you want. But for instance, if I already know that I want this person to be able to do everything with S3 in this account, I can search for S3. See here, Amazon S3 full access. So this one grants full access to Amazon S3, and everything, all the AWS resources have similar kind of policies already existing that you can attach. Amazon S3 full access, Amazon S3 read-only access. You see Amazon CloudWatch full access, Amazon CloudWatch, like all those kind of policies already created. And the type of those policies are AWS managed. AWS managed policies. So these ones are not the ones you created in your account, but you can create some in your account, okay? So now back to what we were talking about. I'm going back to there. I'm not creating any new policies. So you can attach multiple policies to one identity. So you don't think, okay, I've attached this policy, how do I modify it just to attach? You can attach multiple policies to an identity. And this is what the policy, an identity-based policy, this is what it looks like. This version stays like this. I want to mention this because when I first started working with this policies permissions thing, I thought here I was supposed to write the current date. So I edited and put today's dates, like say 2025, 03, 08. Yes, that's what I did. And I was getting errors until I realized like this is the standard. This is the version like of, I think, when this whole permissions version of this setup is. And you have to use this 2012, 10, 17. So you have the version, and here you have the statement. This statement, as you can see, is a list. So all of this, you can say it's like JSON. It's JSON format. You see here, copy JSON. It's JSON format. So you have your policy objects. There's the version. There's a statement, which is a list of statements. You can have only one statement there, or you can have multiple statements in one policy. Here we have one statement, so we don't need to add any other things. But if you have multiple statements, you may want to put the statement ID there to be able to, differentiate and all. So here, this statement, the effect is to allow all the actions that we have in our action list, and the resource here is every resource. So here I'm able to do everything in IAM service, this IAM service. And then I'm able to do organizations, describe accounts, describe organization. These are all things that I can do with IAM full access. Power user access literally grants access to, you can see this one has multiple statements. You can see in our list of statements, you can see different objects, but they all follow the same pattern. Now, you'll see also that instead of an action here, there's a not action. Remember, I told you that power user access grants access to everything except the IAM, and then this account includes like all the, you see here, this is, okay, IAM, organizations, accounts. So it allows everything except for these ones. IAM, organizations, accounts. This includes all the things that I said like this user is restricted from, and then I had to attach an extra policy to grant the access to the IAM. But essentially, you can see it's a simple format. You don't have to cram it. You can always just go online and check it, and you can write a policy you want by yourself. Version, statement, and then the statement is effect, action or not action, depending on how you want to structure it. But you usually use action, and then resource. The resource is exactly what you want it to be. You can use all, but sometimes you want to restrict it, and you will get to see patterns on how to restrict it particular to a resource or subsections of a resource later. But now we've looked at an identity-based policy. Now, a resource-based policy. I think it's the last part we're going to look at, and then we'll go back to our code straight away to be able to work with it. So now we've seen like this is what policies can be attached to identities. And to look at resource-based policy, I want to find the resource. Access to resources. Okay, there's no resource-based policy here. Let's see. Yeah, this is... Okay, there's no resource-based policy here. But I should be able to show you an example resource-based policy. At first glance, they may all just look the same to you, but they are not. Okay, so this is a resource-based policy. Yes. Yes. So, okay. Now you can see effect, principal, condition, action. The thing is, this is attached to a policy, to a resource, not to an identity. And you have to interpret it like the same way. Let me see if this one is a different kind of, yeah. You have to interpret it in the same way, saying that, okay, effects, this is what I meant by the statement ID, SID. And here, the effect is allow. The principal is allowing all principals. The condition, this condition can be any way you want it. You may not even have a condition. It can be any way you want it. You can check for something like, okay, I want to check that this IP address is coming from here, or this principal organization ID is this. There are different things you can check here in the string equals, in the condition. This is string equals. It can be string contains. There are different conditions. You can always look up the conditions. But I always say you don't need to cram anything. And the action, you can see it's the same kind of pattern. You have the AWS service and the action in that AWS service. This is what I was saying, that you may want to restrict the resource to particular resources sometimes instead of just putting all resources. But essentially, this is what it looks like. You attach this to the resource, not the identity. So this one, you're going to be attaching it to your SSM. Yeah, I think this one is for your SSM incident manager, like to allow users to be able to access or to handle these details. But this is what resource-based policy, identity-based policies are. And you can use it to manage what can access what. Now we can go back to our projects. So if you were not with us last week, you may want to go to the AWS CDK and just clone the GitHub repo that we were working with. Is AWS CDK last one that the last recap that we had. There's a link to the GitHub repo here, and this is where we are, and this is where we'll be continuing from. So today we're going to set up the permissions for everything we've built, and then we are going to set up auto-scaling. Now we have one EC2 instance deployed. We're going to make that work. And then when we see it works, we are going to change that one server and use auto-scaling instead, auto-scaling group instead. So where we are at, we need to, resume here. The project we were working with is AWS 101. Let me open it up quickly. This is the project that we were redeploying, and we'll walk through everything again just to check for all the access that we need to get. I'm going to check my CDK projects. I didn't make any changes. Yes, I'll just check in my terminal to redeploy. If I pulled it down, I think I should have it running. But if you pulled it down, you should have pulled it down so it won't be running. So I will just CDK deploy from our folder, the root of our project, and if everything is pulled down, you should deploy it again. I think this is the beauty of infrastructure as code. Yeah, you can easily use one line of code to redeploy everything you destroyed or just pull everything down without forgetting anything behind. So yeah, CDK deploy. If you are just starting from here, you want to make sure you are logged into your CLI here, and then you can continue. If you're not logged in with your AWS identity, you won't be able to follow in the terminal. So what did I do? Okay, it seems like I pulled it down, so it's redeploying stuff. And yes, why this does its work, I'll continue. So going through everything again, setting up networking. We already have our VPC, we have our availability zones, we have 2 of them. I remember last week we kind of created 12, like it was like what was it, like 4 in each availability zone. 4 in each availability zone. That was 3 availability zones instead of us to have 2 in 2 availability zones. So we rectified that, and you should have just 4 total. We have our subnets. Let me see what is okay. I think we're all done here. Deployments. Yes. So we have our subnets. We have all of this set up, NAT gateways. Yes, also NAT gateways. I'll just pull everything up so we check it together. We have our NAT gateways. We have everything set up basically. I just want to see what we need to. NAT gateways, yes, 1 in each availability zone, if I'm correct. Here you can see all the details on this. Okay, so see all the details on both of them. So you can see public subnet, subnet 1, public subnet, subnet 2, like that. And we're following this architecture. Where is it? Yeah, following this architecture. So now we have everything that we really want. We need to grant permissions, okay? And we're looking at our infrastructure to grant permissions. There's still one more thing that we need to do with our server, but we'll come back to that. So following the arrows, we need to check that we have all the access that we want. Our NAT gateway should be able to connect to the internet, of course. NAT gateway connects to the internet. Our internet gateway has access to our, like, it grants access to our VPC, like from the internet. We have our load balancer security group. So the security group for our load balancer also needs to grant access from the internet gateway into our application load balancer. Like, our security group needs to allow the internet gateway connection, and we need to configure that. Let's see. That's a security group thing. That's not identity or resource-based policy. That's a security group that needs to grant access. So we are going to our security group. Where is it? We have 2 security groups. This is our load balancer security group. Yes. Okay. And where is, we have, okay, our VPC has our internet gateway. Yes, create internet gateway. Okay. Yes. So, like I said, we have our CDK here, and our security group was created in the EC2. So remember, whenever you're working with CDK, you want to actually keep this documentation very close to you. You work with it a lot. So AWS CDK Leap, this was Autoscaling that I was preparing for us to work with. Firstly, we'll go to AWS EC2. Here it is. This was where we created our security group. And with it, we are able to also check. Let's put this a little smaller so we can have, let me see. Yeah, the full page. So this is the security group. And when you go down, not this part, not the properties, I want to go down to the, so the methods on the security group. These methods are, you are able to call them on the security group that you've already created to modify it and add, I don't know, make changes or add routes or add access, remove access that you want. So here, what we want to do is to grant access into the security group. That's the ingress. We have ingress, like INGRESS, and you can have egress, EGR. It's basically in and out, ingress, egress. And you use this to grant access into your security group or out of your security group. What your security group does is it's like a firewall, I would say, like a very simple one that just decides what goes in and out of that small space, basically. So the security group is, this is where our load balancer is. And for anything to get to the load balancer, it has to go through the security group first. That's why we need to grant access on the security group, or rather, the security group. I want to show you what the security group currently looks like. So we'll go to our AWS console, we'll check security groups. Okay, this is what we have here. Anytime when you go to your console and you cannot find what you are looking for, first thing to do is to check if you're in the correct region, because sometimes that's the cause of your issue. So we're looking at our load balancer security group. That's this one, and let's see what the inbound rules currently are. There's no rule coming into our security group, basically nothing for our inbound rules. An outbound rule, there is a rule for the outbound. There's always this default rule for outbound. All traffic goes out, as you can see. By default, all traffic goes out of your security group. There's nothing limiting what goes out of your security group. So we only need to set our inbound rule. By default, that's how it usually is. You only need to set what's coming into your security group. The security groups are stateful. They remember and then they go back out. But the network access control list, which is a different topic entirely, this one is tied to your subnets. This one is limiting what goes in and out of your entire subnet, okay? But we're working with the security groups right now. The security groups, you only need to set the inbound rules. And now we're going to be setting this using this ingress. I don't know, we talked about it. Yeah, yes. So this is going to be add ingress rule for the current security group. That's what we're going to do. Okay, so let's look at it. This is it here, add ingress rule. As you can see, it's just, I think the main thing with programming with this whole AWS CDK thing is knowing where to look for the document, like what we want to do, because it's all there. So we're adding ingress rule. We're going to call our security group and we're going to call this on our security group. So we're adding ingress rule and see there's no, okay, let's just do it here. So there it is. I don't know if you can see what I'm doing very well. If you can't, you can drop a message in the chat and then I'll make it bigger. But here we have our load balancer security group here. I'm going to call the add ingress rule method on it. So with this method, you can see the first thing here is the pair. So we can say, okay, if I want to allow access from another security group, I can use that as the peer. It's like let me show you. There are different things that could be peer. You could use cider block. You could use. Let me show you the interface peer. Yeah. So you see, it could be peer. These are some ways basically. Prefix list. This one prefix list is usually a pre-provided like list like AWS. I would say AWS IP addresses. You just see it as a prefix list. Like, okay, prefix list, this represents S3 locations, or prefix list that represents something coming from AWS side. So we could have security group, we could have IP addresses, we could have, basically, you could use different kind of sources for this particular entry point. So if you're not sure what you're meant to do with something, you can go and look at it. You'll see all the different things that you could put in that area. Back to our security group topic. Now we are going to be doing add ingress rule. The first thing we have here, as we saw, is our peer. And we're going to say it's a new peer we're going to be adding. So it's going to be new peer. Or let me just do this and say peer dot, it was IPv4, I think. Let me just do it the normal way. Peer EC2.peer dot IPv4, and wait, oh no, it's true. We're allowing ingress from the what they call this thing, from the internet gateway. Yes, so that should be different. If we say allow any IPv4, that's automatically allowing 0.0.0000. But for our internet gateway, we can have a look here in our console. And yeah, so these are the internet gateways we have. We have for our websites, VPC stack here. Okay, internet gateway ID. And that would be, instead of doing this whole IPv4 thing, we can just put, I think, from our VPC that we have, we can put the VPC dot, should be internet gateway ID. Oh, sorry. And the connection should be which ports that we're allowing it in on. So I think normally we would want it to be on the 443 or 18. Let me see what we have going out would be in a moment. Where's this? Now this workshop. Okay, not here. I want to see the rules that we have for our security group. So we have the security group allowing external access in the inbound section of our routes. Oh, okay. We didn't actually allow only from the we allowed everything to come in from anywhere. I'm guessing that should make sense because the internet gateway is allowing everything from the internet. So we'll use on port 80, this same platform. From port 80, we're going to use anywhere. That's the any IPv4 option for our peer. And this is the description we would use just because they said we should use it. So we're using this inbound rules for our stuff instead. Where is it at? So I'll still go in the same routes. New EC2, let me just put this and say EC2.peer dot any IPv4, and because we don't need to create an instance of that, our port is port 80. Yep, our port is port 80. So we're saying ec2 dot port dot http. As you can see from this page, it's http, so you can just use that directly. Okay, and where was the page I was in just now? And the next thing would be the description that we wanted to add, and allow http from the internet. This allows everything. So all the connection that's coming in through the internet gateway, since it is from the entire internet, is going to be allowed here. This allows everything, and that's for the ingress rule for our load balancer. Then let's see, is there anything we're adding again? No. So the other security group for our web server, we're granting access from our load balancer security group to our web server. You can see that in the, where is this? You can see that in the architecture diagram here, that's there is, okay, no, this makes it smaller. There is this arrow coming from the security group of the load balancer all the way down here, and then going to the security group for the web server. So we're going to grant that access, and we're going to follow the inbound rule that they have here. So this one is allowing from the load balancer security group. Remember that the same way we created this inbound rule is the same way we're going to create the one for our instance security group. So we're going to add an ingress rule here. For this will be instance security group dot add ingress rule ec2. This time around, we're not going to be saying ec2.pair.any IPv4 because we're not bringing from a particular IP addresses. We're bringing from the load balancer. So we can just mention the load balancer security group directly here. So I'm going to be load balancer security group. And yeah, I think, let's see. No. Dot security group ID should work, I believe. So it should just be in the security group, but we need to change the order because I mean this is CDK. It's not declarative, it's imperative. So in the order in which it works is how it's going to be created. And if we're going to be allowing access from the load balancer, we should have created the load balancer before it. So I'm just going to move the order of this. I'm going to put it under the load balancer so that the load balancer already exists by the time we are referencing it. So adding the ingress rule, the first point our pair is the load balancer security group, allowing access from it. On which port, I believe we're also still using the EC2 port 80. That is port dot http, yes. And the description would be what we have here for us. So allow HTTP inbound from the load balancer. Then we go back. So here we have, so I'm just going to add some comments because our project is getting really long, so we know what we're doing here. So this is our VPC. Yes, it's important. Forgot the language I'm writing in. This is not Python. This is TypeScript. Yeah, so the comment is this // and VPC for websites stack deployment, and we go down a little where we added our S3 configuration. This is our S3 bucket. I see keep S3 bucket, just to separate everything properly. We are adding for load balancer. This is the load balancer security group. I haven't added the load balancer here. I probably added it somewhere there, but I'm going to make that all different. So this is S3 bucket configuration. You can add comments in yours to organize it better. This is EC2 instance configuration. So I need to arrange it properly. This instance goes with this ones, and then also our load balancer should go where our load balancer configuration is. No big deal, it's just some house cleaning, or like we say, home cleaning. Yep. So everything looks okay now. We can continue. So load balancer EC2, yeah. So we are done with our inbound rules for our security groups and all that. So far, I'm repeating, we have not worked with the access stuff. So now, all the things that we need to do with our access, we're going to do it in this code. This is the part where we do the IAM management, and that's why the preamble of all that was necessary. So we're going to go. This one, they're saying, oh, EC2 role we need to create. The role is already created for our instance profile. I believe that. Let's check our code again. Commonly SSM. This one, it created manually, yes. But they want us to create a web instance profile. If we check our EC2 instance here, I'm going to my EC2 to check it for us to look at it together. We have this EC2 instance, and when you look at the details of this EC2 instance, we'll be able to see if we have an instance profile or we don't. It should be able to see. If we don't, we'll need to create it. But at the moment, that should be instance ID. No, I see it here. The IAM role. So when you check it, you see all the things that they're talking about. You see it already there. Okay. No, we haven't yet attached. Okay. So the instance profile is created, but we need to still attach the policies that we want our instance profile to be able to do. I think there were some special policies that they set. But when you look at this instance profile that is created with our instance, our EC2 instance, you see in the trust relationship, there is already the configuration to allow the EC2 service to use this role. So this is necessary because if we create it without adding this trusted entity, this trust relationship, our instance won't be able to use the role at all. So it's a role, and our instance is able to assume it when it wants to do things. Now let's see, what were we asked to attach to this instance? Let's see. We were asked to add, we want to attach the role for Amazon SSM Managed Instance Core. So that is the role that we want to attach to the EC2 instance. Okay. That's not a problem. So we go back to, here we have our EC2, what is it? Instance, yeah. So we go back to our EC2 instance, and in the methods, that's the thing, you always find what you want here. Coming, these are properties, that's not what we're looking for. We're still going to have to set our user data here, but that's not what we're looking for yet. Yes, so this is it. Add to role policy. Okay, so we need to add to role policy, And there's also this one that would add the user data. I'll show you what we're talking about later. But this is the add to role policy. We want to add a statement to our IAM role that we already have. And what we want to add is this Amazon managed instance core that it told us to add. So we're going to go to our instance and call this method on it. It's usually that simple. If you want to make changes, go to the documentation, look at the methods, the properties you have there, and find how to add it. I don't cram these things in my head, but I know they're there, okay? And here we have our VPC. Let me just minimize this when we're not using it. The load balancer. Okay, we're adding, this is the instance configuration here. Now I want to add instance dot add to role policy. It's a new policy statement that we're going to create. We're going to add to it. So this is going to be new, okay, and it's going to be I don't think I've imported. I need to import it if I haven't. Yeah, I've not imported it. So I'm going to import it, add the import for the IAM. From AWS CDK lib / AWS. You always have to import these things if you need it. Yeah, IAM. And that's it. So we're using this to add the policy statement. So this is going to be new EC2 dot, no, sorry, no, this is IAM dot, we need policy statement, and we're going to create it the same way we have been creating our props. So we need the policy statement props. I would need to check what the props are, but instead of us going to add all the effects, allow and all that, this is how you would do that for a policy that you are creating from the scratch. We can use the managed policy that is already created. We don't need to create a new policy statement. So we can use the managed one that AWS already has provided for us. And we can use policy statement. I think we should be able to say dots, or is that a way? No, I think it should be managed policy statements. But let me see. Yeah, managed policy. Dots from AWS managed policy, or we can say from managed policy name. So we just need to put the name of that one that we use. So this is the alternative. I could try to create this, but this is already existing in AWS. Remember the list of policies that we looked at that time? It's there. So if I write this, it should be able to use it. And I don't need to put new here anymore. Let's see. Okay, because I put add to role policy. This is saying let me see. We're going to use this manage policy statement, but the construction is not correct, I think. So I'm going to rewrite it. I'm going to add the new policy statements. Policy statement dot It's not allowing us to do that. But yeah, I'll just go with this. I'll go with this, and I'll draw up the policy statements to see the way that we can actually get it from our the way we can get it from our managed policy, because we don't want to start putting. There's a reason we use managed policies for some things, because when you try to add it all by yourself, then you tend to miss out some particular permissions that cause issues. So this is example of a policy statement, but you see this is creating it manually by yourself. I want to see the options for us to actually add the policy statement from let me see, policy statements. Now this is not what I'm looking for. I'm just going to add it instead of this. Let me see our instance. Let's see our instance properties directly. I think that's the other option. We are trying to use a method on the instance, but maybe it's just best for us to set it the other way around. No, this is too. And then we wrap up some ein moment. Yeah, EC2. We have our instance, and I want to check the policy stuff. So this is the instance profile. We can set some things on the instance profile if we create it ourselves, or which one should we do? Let's use the instance profile instant. I think that would be okay. Not this one. I guess we'll just do it they are doing. Okay. I am policy statement. I didn't want to have to build this manually, but we'll do it. So I just feel there's still a way for us to actually use it without having to do this. We will have to create the role separately and attach it to this one instead of writing this particularly, which is a longer route from what we've already done. But we can still leave the policy empty. We'll come back to build it, and we can add the user data. I also want to add the user data. The instance.add user data, because we have this let me show you. It's here in our code also. We'll come back to it. That allows us to launch our code. Yes. So we want to add this user data. And yeah, it's a lot. Add user data. Okay. So we have all this command that we want it to run on the start of our code. So you copy it from the AWS 101 workshop. It's there, and if you want to go through it, it's basically setting up the server, like HTTPD, setting up the server, enabling, starting it, and your web pages and all that stuff and getting it to run. That's what it does. So when you start the server, this works. And that was the last thing that we needed to handle for our yeah, we cannot skip this. So for our instance, I think what we had was to grant access for the SSM administration that we want to do, and I think I would do that now. So instead of trying to add to the role policy directly, because it wants us to create an inline policy, which I don't want us to do. We want to use a managed policy. So I'm going to create a role for the instance that we will use for our instance. You can put it anywhere in your instance. So specify the role. I think that's the best option for us. So we can move on with this. We create a new IAM dot role. Yeah. Or we can actually, instead of using this role, we can just create instance profile directly. All of it, they are all options. Instance profile, particularly, I'll say new IAM plus instance profile. And yeah, so the scope is this. This is the scope of what we are building. The instance profile will just be web sites. The way I used to create it, I'll create it the way I used to create it. I build it from my ID. So it's a concatenation of this, and we'll say instance profile. There are times we'll have to do this. And now the instance profile props, what we want to set for our instance profile. We need to go and check what the values of the instance profile props. Is this it? So this should be instance. Yeah, but from here we can go to instance profile. Yep. Here we have it. So instance profile. The instance profile name and then the role we want to. If we didn't create instance profile, if we created role directly, it should use whatever role we created. For the instance profile, it will automatically create. So that would be name following the exact same, no, not this one, name like this, and it's going to follow the exact same pattern that I did just now. I just copy it actually. You'll be wondering why I'm using the same thing. So this one here is the ID like in the stack deployment, and this one is going to be on the instance profile like in the list for our stuff. So instance profile, yeah, it does. Oh, instance profile name, instance profile name. And the role we wanted to use, we have to create our role because we want to use our own settings for the role. New IAM role, I'm going to be creating it this way. Construct, the scope is still this for it, and I'm using the same pattern. So this one is going to be instance profile role, and our props for our role, we need to check the options that we're meant to put in. So yeah, we have it. So this is what the role looks like, and these are all the policies that we want to add to it. So we need to set this up properly. What can use this role? This is going to be assumed by, am I going to be setting EC2 services is what can assume this role. Exactly what I showed you in the example that we had. I don't know, it's not open here, is it? Yeah. This is what we're saying. This is what it's trying to set up, like what can assume this role. So we want to allow EC2 instances to be able to assume this role. I think it's a good thing that we're actually having to create it from scratch like this. Yeah. So the assumed by for us is going to be I am dot C, that should be C principal service principal is a service principal dot let's create this. So the service is EC2. Yeah, I believe it should be EC2 dot, is it? Can always check the service principal should be here. So the service principal should be the full, yeah, like this, ec2.amazon AWS dot, and that would be amazonaws.com. And we have, after the role, this is the role, we have, okay, we want to attach, let me see, what options do we have in our role here? No, not this one, yeah. So our props, now we can add manage policies. That's what we were not able to add before, which brought us all the way here. So we can add the manage policy now instead of just inline policy. And the manage policy we want to add is, let me see which one. There's a list of manage policies. Let me see which one we have. EC2 dot managed. Oh, sorry, I keep saying EC2. I don't know why. I am dot manage policy dot from manage policy, from AWS manage policy name, and let's see what we have in our list here. I already closed it. I'll go back. It was AWS SSM something. Yeah, it was this one. So we just take it and put the name there. So we had to create our own role by ourselves to be able to do this. Remember to add your commas so that nothing breaks. We had to add our own role to be able to attach manage policies like this. But now we have this set up. We added our user data and we can now configure, okay, our service to have access to all the things we want it to, I guess. So we have exit exactly, deploy our EC2. We've already put our configurations. We've set up all the services last week, but we have not added, I want to confirm that we added them to the correct security groups. Okay, yes, so the security group for our instance is there, and also for our load balancer, their security groups must be there. Yeah, the security group for our load balancer is there. Okay, so they will have access to each other. And I think that's all from here. The only thing else would be load balancing, and we can test the stuff. So we've created our load balancer, yes, but we have not it's just there. Basically, it's just there. We need to configure the target group that he's going to work with, and that is going to be looking at this. Where is it? Looking at this, the target of our load balancer is our web server, it doesn't know automatically. We have to create a target group and configure all of that and let it know. When we change this to an autoscaling group, it's going to be an autoscaling group instead of the web server, but everything is going to be there basically. So in this our code here, it's going to be okay, this is the load balancer. No, we already have that. Our target group, yes. Now we need to create our target group. So this target group, this is the configuration for the target group we're going to be creating the same way. And yep, let's get started. So we can always check it here, but it's basically the same. It's going to be in, where is it, AWS EC2. If you can't find something, check. Okay, it should be in elastic load balancing. So we have the application target group because we're using an application load balancer. So we're going to be creating an application target group, and this is exactly what it looks like this. You have to have your listener, your target group, and then you set it up like that. So firstly, we are having our target group, yes, like this. And let's just configure this. So constant target group is going to be a new ELBV2 dot application target group, and we're going to be using this scope. Will follow the same pattern for our naming of our stack resources. So it's going to be $ID and load balancer target group. That's what I'm naming it. Very intuitive, huh? And then the next thing is the props. So it's just going to be an object of all the properties we need to set for our target group. So our target group, we need to set, where is this? We need to set, okay, the target type is going to be instances, target group name. We already have, let me see, we've not set that. Target group name is going to be, sorry. It's going to be the same thing. I'm using the same thing. Okay. Target type is going to be, let's see, instances. Let's see, it should be ELBV2 dot target type dot instance. See, and then we're going to be adding the port. It's going to be HTTP 80 protocol. Port is going to be EC2, not ELBV2, because the port is under EC2. Dot port, or you can use protocol, depends, but we're using port right now. Dot HTTP. That's what's going on here. Okay, this expects, let me see. Oh, this expects the 80. We can write it directly here. This one expects 80. Let me see if there's an ELBV2 dot port. No, it doesn't. So we can write either port or protocol, whichever one you want, but let's use protocol, I guess. Protocol ELBV2, no, EC2 dot protocol dot, I think it was TCP we had. Wait, let me see. Okay, no, protocol was HTTP, then we had, protocol was HTTP, of course, I don't know why I said TCP. And then they had port 80 protocol dot HTTP. It's not here. It's be port dot HTTP. What's the problem? Application protocol. ALBv2 dot application protocol. It's expects us to use this one. Dot HTTP, not the one from EC2. I guess they're very meticulous, even though they're both HTTP showing here. And a lot of other things we're setting are optional, but because we want it configured in a particular way. So the IP address type is IPv4. Do we need to set all of, let's go see if we need to. IP address type is ELB2 dot, let me see if they have IP address type dot IPv4. What's the problem now with this one? IP address type. Target group IP address type. Okay, he wants us to say target group IP address type. Reading your errors can give you a lot of like save you a lot of headache, because you can see it's the same things here kind of, but from different enums, like from different lists. So don't assume they work for each other. We said that the VPC is going to be in, we have to set it. The VPC is going to be the VPC we have here, so I'm just going to reference it. VPC is going to be VPC, basically. We already have it here. And next would be protocol version. Really? Okay, protocol version, let's go. Health check protocol also, we're going to be setting everything, just converting it exactly. So we're going to use ELBv2. Let's stick with everything ELBv2. Application protocol version is here. Dot. Some of these things are set by default, but just to fulfill all righteousness, we set everything as dictated here. The health check protocol is HTTP. We're going to put that here also. The health check. No, this is not. The health check path is what is going to be showing here. Yeah. So this one, we have to set a whole configuration for our health check. All these other things are going to be inside it. So we're going to say new ELBv2 dot, should be health check somewhere. But let me see. It should be. There should be health check here. Let's check our reference point for our application target group. Yes, health check. Yes, it's a whole different. Yep. Health check is in ELBv2.health check. Yes. So I'm wondering why it's not showing it. New ELBv2 dot. Let me see if it's application health check. Oh no. Targets. There's a bit of a. Let me see how it's created. The target group health check. This is. They configured the health check after, but I wanted to add it in our. So this is under, let me see, ELBv2.health check. So we should have it here. It should just be here as health check. Why am I not getting it? Maybe we'll just attach it after for our target group also. Let me see. Target group dot configure health check. I don't know why it's not allowing just to set it in. So it's still the same thing. We'll still have to check to add there anyway. I will just add the values. It's not allowing me to create a particular, so I will just create the object since we just have the objectives. So I'll add the health check, base target group props. Okay, it's a different type, base target group props. So I can create it like this. That's the difference. So the values for our health check would be our path, exactly what we have set here, health check protocol, health check path, and that's all I'm putting. We're out of here. So we have the health check. Okay, this is healthy HTTP code. No, just put a path for this one, and that is like this. That's what we have in our code, and we have the protocol. Let me see. Protocol is, which type is the protocol? Is health check dot protocol type. So we're going to have to call the ELBv2 dot application protocol dot HTTP, right? So this one just wants this one doesn't want application protocol. It wants just the normal EC2 protocol, I guess. Dot protocol dot HTTP. Oh, no, not this one. Not this one. It's the ELBv2 dot just dot protocol dot HTTP, not application protocol. And after this, we've configured our target group. There's nothing else we need to do except we create our listener. We've not created our listener yet. The listener on our load balancer that connects it to our target group, and then we can now connect it. So let's check what our listener has. This is the application load balancer. Where's the setup for the listener? We need, okay, let's see what our listener. Okay, we need to set up, let me just create it. Constant listener equals to new ELBv2 dot application listener. This same way we create everything else. ID load balancer listener, and we add our props, like the properties for what we're creating, and that would be we need to check what our options are here in our application listener. It's not much more anymore. This shouldn't be much, just the port and whether it's open. Let's see. So if we're doing this, we can put the load balancer here particularly and set the ports and protocol directly, or we can actually use, so we can create it the way we're creating it, like this. Load balancer listener, set our load balancer and all that. Or we could have used a method on the load balancer to add it, but so why do I have this? Should be this load balancer, and what we have is an open load balancer, an open listener. I believe we Yeah, it's open. I think this should be default anyway, but let me just leave it out since we just need to set this. So with this listener, let me see, default target groups for this listener should be target group. This should be a list, and we need to add it under the target group. No, I moved it too much. So we're creating it under the target group because we are referencing the target group which we just created. So we've connected everything here. I believe nothing is still left open. I believe nothing is left open. We can just check this. Our listener is port 80 for our target group. Let me just mention that there. Port is LBV2 dot port listener I saw it here somewhere. I'll just put it, no problem. It's port 80. Port 80. And that's what we have. Okay. Protocol. I mean, if without protocol or port, anyone works. Port 80. So what we have now, we can try our CDK diff. CDK diff is going to show you the difference on what you currently have in your AWS and what you have here. What difference? The name for my target group is very long. The name for my target group is very long. That's what it's saying. You should get the same error if you have a name as long as mine. So we'll just go there and reduce the name. I'm not going to put, instead of this, I'll just put target group. Instead of writing load balancer target group, I'm just going to put target group alone. And that should make a difference. So CDK diff doesn't deploy, but it tries to kind of like compute and see all the things you've set here and check the difference of what you have in your AWS environment deployed and what you have written here and show you what is going to change. So we just want to see this. So it's going to remove the previous role we had because we defined a new instance profile role, remember? And you can go through everything and see all the things that are going to change. It's very clear. These are the changes in IAM statements. There's a role that's being removed. There's a role that's been added. We added a new policy. That's the managed policy we added. The security group, there are changes in our rules. And it's showing you the direction in which it is. So you can assess everything that you're doing here without applying it yet. So it's going to destroy 2 items, is adding, all this green is adding new ones. The yellow says it's changing it without actually deleting it. It's just changing it somehow, you get. And yeah, this is all we have. Okay. Let's try deploying this. Now we can run CDK deploy and we are going to watch it deploy. That should be it. Yes. There's another thing I want to show you quickly before we go. We'll do this. What's the call is? The user data CDK from file. I think we should be able to do that now. Okay, yes. So trying to add user data from, because we had the user data that is these are different things you can. This one is 2. it is like trying to build a user data. But I wanted to show you how to add a user data from file. I think we can try it, or you can try it by yourself. Where's my code here? We added it inline here, but you can save it in a file. And let me show you. Like for instance, I'm just going to try and write this, like instance dot user data dot user data data dot. So this one is you building the user data by yourself. I'll have to check it again and update it in the recap. But I built the okay, no, that was adding the lambda commands from a file. Yeah, that was adding lambda commands from a file, not the user data. But let's have this running ASAP. So what we have here works fine. The only thing that's going to change is we have set all these things, and you know we set the target for our application load balancer. So when we created this target group, we wrote target type dot instance. You can now change it to target type dot. Okay, it's still going to be instance. You can change it to the lambda function. You can change it to IP address. You can change it to another application load balancer, like when you nest different application load balancers. So it's going to be instance, but instead of adding this, we haven't even connected it directly. Actually, yeah, we haven't. We have the load balancer, we have our target group. We have not added our EC2 instance, to the target group yet. I'm just checking it. Yes, you haven't. But essentially, it's the content, the direction of your load balancer is going to your target group, and you can change what that target group is. You don't need to change much in your load balancer except if things change. So when we create an autoscaling group, we're just going to replace, instead of our instance, we're going to replace our instance with the autoscaling group of instances that have the same configuration of this. So I want this to finish deploying, and we'll just change that, and then we'll see how it works. So we used a single instance here. Our autoscaling group is still going to use the same security group as our instance, the same configurations and everything, but it's just going to be an autoscaling group instead of that. So here, I'm coming, not this page. Here we see application target group. So this is what we currently have. This is what we currently have. And we didn't need to set some settings because we were not having different multiple instances, and or we have only one instance. So we didn't need to allow it to balance, to use multiple zones to balance or anything. We didn't need to do any of that. But these are all different things that we can set. So yes, here in the targets is where you will now set which targets you want to add to the target group itself. And that's where we're going to set it. But for us to do that, as usual, we need to rearrange it, because if you look at our code here, our EC2 instance is under our target group, and we want to add it to the target group. We need to move it ahead. Another option would be for us to just come down here after everything outside here, and we'll call like our target group dot add targets. Instead of having to put it there, we can always add more targets. Add targets, and we'll put the instance that we have. Is this going to be a list? Attached to application target group. No, I'm coming. I want to understand what it's saying. Attached to application target group. There needs to be a difference for this. This is our target group, yes. I'm coming to see the methods to add target group, to add targets. Because I'm wondering why it's not accepting that target. Yeah, you're supposed to accept that. Okay, we have to, if it's a single instance, we have to set it as instance target, not just the instance directly. But if it's an auto-scaling group, we can put it directly like that. Yeah, that's the difference. So for this one, we have to create instance target and then just put it like that. So that's what we're going to do, instance target. And that's what we're gonna do, like this, add target. So we have to create a new instance target. I've not tried putting, let's put application target. Where is it? It should be EBV2 instance targets, yeah. Oh, we have to separately. Yeah, we have to separately import it. That's why. Import as. We'll still have to remove this in the end, but I mean, or instead of removing it, we can just add it because we are still going to just add our the last step of our stuff. If you are looking down at in my screen, you'll see that what we are deploying has finished deploying. Isn't that awesome? This is targets. We have to import it separately. Sometimes AWS can be annoying, but I mean we live with it here. So for this, we should be able to do ELBv2 targets dot instance targets, and we add our instance here. Okay, put a port, or just leave it since we already set stuff like that to be default. And this is, we've added our target. Here, what we deployed before has finished deploying. I could easily just quickly deploy this and add the target, but I also want to add our auto-scaling group. So I'll just add that and deploy everything together, and then we wrap up. I mean, we check it and then we wrap up. So we need to create auto-scaling group. Okay, and that is a separate thing. So if you check here, what is it? Auto-scaling, AWS auto-scaling. It's a different on its own. Here we have it, but I want to be sure it's what we're looking for. Yeah, it should be application auto-scaling. These are all different. Interesting. Interesting. Let me see, is it two? Yeah, so then we have auto scaling, and then we set go. So application auto scaling, scalable targets. This is not what we're looking for. You can set up different scaling. Let me see which scaling. I think we did the normal scaling for our stuff. Okay, it was a challenge they gave us. The one I implemented was like scaling based on CPU usage. Yeah, and we'll just do the same thing here. Scaling, where is it? Scaling based on CPU usage. You know what we're going to do. And that should be, where is it? Auto scaling. So we'll create our auto scaling group and then we'll continue going with that. So auto scaling group, and would use our, let's just do it. Yeah, we're going to use the same configurations we used for our EC2. We'll put it here with the user data, everything, and then we would add it as a target and it should work. So autoscaling is basically taking in a single configuration with extra configuration on top of it. That okay, this is configuration for my instance and all on my instance types, and then extra configuration on how I want to increase or decrease them as necessary. So I'll just add this quickly. Auto scaling configuration. So we're going to say auto scaling. On the auto scaling group. Scaling group equals to new. Let me import it. I need to import it. Make sure to add your import if you haven't. Import as ASG. We're using ASG. Try to keep things short here because a lot of imports keep going and it gets longer. This will be AWS Autoscaling. That will be it. Then we go back down and continue what we're doing. So autoscaling new ASG dot autoscaling group, and we use the same method we use. Our scope is this scope, and we're using ID ASG. I'm just going to put ASG for autoscaling group. I mean, you know what that is. And our props, now we can do that. So you would want to reference what we have set up in our EC2 instance. Most of the things we have here, we can just add it there. So I'm going to copy everything and put it there, and anyone that is not needed, we remove it instead of trying to type everything all over again. So I'm going to put it here, and as you can see, everything actually works except instance name. Yeah, we didn't need instance name. Yeah, but I think we should be able to have a name for our autoscaling. Let me see what name they use. Is there a name? Autoscaling group name. So I'm going to use that instead of instance name. But everything else goes. So we just copy our exact configuration and we use it. What's this? Auto. Okay, I want a capital S. I think I also want the capital S here. And instance profile. Okay, yeah. So instead of using instance profile the way we did, let's see what we're going to use here. Instance monitoring, instance type, machine image. No. I'm looking for the configuration for the profile. So here we're only able to set the role, not the profile. It's going to have to configure that by itself. So we'll just take our role here. You see, that's what we're going to use. We're going to take the role. Or you could remove the whole thing and try to type everything again from the scratch yourself. But we're going to take that basically and set it. I'm formatting the document so everything is arranged. And it's still red because not everything is const. Yeah. And we still need to set some things. So we've configured this, yes. We have our autoscaling group, but how do you want things to work? You can make that a way you want it to be. For me particularly, I want to say which subnets I want it to work in, where the instances should be placed in the VPC. Here we just add the VPC. We didn't specify. We have the security group, yeah, but we didn't specify. So we need to set which subnets. We should have actually done that for our EC2 instance too. Maybe we'll do that. But the subnets that we want, let's see, our subnet selection would be, there are multiple ways we can do it, but we can say new EC2 dot subnet selection. Subnet type dot. If we want this to be in our private isolated, not new EC2, private isolated, but we want to create it from our subnet selection. So our subnet selection is going to be based on the private isolated. And what we can do is we're going to put the new EC2 dot, I think it should be subnet, let me see. Yeah. Let me copy this. So for this, it's going to be subnet type. There are different ways we can filter it. You can put a list of the subnets, you can put the subnet group name, you can put a filter. But we're using subnet type to select it. We're going to set this. So it's going to use this subnets, this private isolated. Remember, they are the ones that are fully restricted, no access to the internet except through whatever we configure and the access that we configure. In this diagram here, there are these ones behind private subnets. So we want our autoscaling group to put in both places. And that's what we also should add for our EC2 instance. We want the subnets to be VPC subnets, the same thing. Come in and put this, the same thing we want. We didn't add it there, so it's going to be subnet type EC2 dot subnet type dot private. It's okay if you don't know yet exactly what's what do you call this thing, properties or methods exists. Like the more you search, you know, we keep running into blockers here and then we look it up and then we see it and then we continue. So it's not everything I remember in my head, of course, and it's not everything that you will remember even after a lot of time. But yes, we've added our subnet type for our autoscaling group, but that's not all. We still need to configure something, yes, but I want to add this target group. I'll add this so we don't forget. We'll add this target. And we can just put autoscaling group here directly. We don't need to go through this instance target thing. This is what I was saying the other time. And we need to add the user data. I don't think we've added the user data. Yes, so we need to add this user data. Let me see. We can say add user data, or we can put it in the code when we're creating it. I just want to separate it because it's quite bulky and I think it's just best to have it separate. So this is it. I'm copying the user data and I'm putting it here too because we want it in our code. And I think we can leave the default autoscaling configurations. You can explore how you want to change that around. I think, where was it? There are different ways you can configure your autoscaling. Like all the different things. Launch, so many different stuff that you can configure. But when we try to deploy it, it will tell us, okay, this or that is not working, but I mean, it's fine. So we use instance security group for the autoscaling group, but you can change it around, specify how you want it to be, and that works fine. Okay, and you can now check this out. CDK deploy. I know we weren't so thorough with this. There's already a construct with webstack instance profile role. Did we? Okay, it's because we're creating a new role in this way. So we're creating the same new role with the same name 2 times. To change that, if we still want to keep the same roles, we can easily just extract this into a variable because it's a new role we're creating inline. I'm going to extract this outside our just put const role equals to what I just copied. It's creating the role here. I'm just going to put it the instance role as the name so we can reuse it instead of creating it twice. I totally missed that when I was copying that. So here I'm just going to reference instance role. It's using the same role, and in the EC2, the autoscaling group, I'm going to reference the same role also. I don't know if you're following what I'm saying. So it's going to be instance role, instance role. I didn't create it twice. I created it once, and then I just referenced it here, and I referenced it here also. This is where it's created, instance role. So I'll just go and run this again. Don't be scared of your errors. I like to look at errors as the fastest way for me to learn. Like when I see the errors, I read what it's saying, understand it, look it up, fix it, and I know more about that, I guess. So now it's being deployed. We didn't need to have the EC2 instance and the autoscaling group, but I just thought, okay, we can leave it and then add this autoscaling group. Ideally, you want to remove your instance and just have an autoscaling group because that would create the instances. Do you get? So yeah, that's what we have. Let's see. You can take some time and scroll. For some reason, our code has now become really long. Yeah. And today we took 2 hours instead of 1 hour. I think it was necessary because we touched on permissions and also autoscaling group and did a lot of different attempts and configuration on things. But we're at the end of the tunnel. And it's currently being deployed. Right now, I think the single instance that we already have should be somehow accessible. Where was this was it. Let's see. So it's our load balancer that we should use to access it because we've granted access to it. And this is what it should, let's see. I know we haven't put anything in the bucket and all, but this is our load balancer. It's active. We have our listener. I don't know, this my screen is suddenly feeling very small to me. We have our listener. Yeah, this one. Okay, we have only one target group right now. This one. Okay, it says one unhealthy. Let's see what is unhealthy about it. The health checks failed. Let's see the instance. We're able to see what the issue is. So it's running. The checks passed for this instance. Yeah. Okay, this looks correct. Let's see everything. All looks good. Networking, security. We have everything that we wanted to do here. Okay. Instance state details. I'm looking for something here. Let me see. What we're deploying has finished deploying. I expect the autoscaling group to also. I'm suspecting. What was the part? I think it was our target group that we saw that it was one unhealthy, and the health check is on this flat part. Let me confirm. Our health check for our target group was supposed to be there. Okay, it was load balancing. Yeah. Target group. Yeah, we put the right head check part. Okay, let's check our target group. Also, show up two targets in our target group. So we have our autoscaling group, our instance type. Yeah, there's still something with our autoscaling group here. Where is it? Okay, we have our template configuration. Yes, it's correct. Advanced details. Our user data. Aha, our user data has. Yeah, I think our user data has. I don't know if you can see this. Let's correct this quickly. Did I? Yep, this is not meant to be here. And now I'll be staying with the autoscaling group and comment out my instance because where is it? I'll be using it, so I'll just troubleshoot this one. I'll deploy this. Let me see, for my autoscaling group, did I add? Let me just add the minimum targets and or the desired capacity. I'll put 2 for my desired capacity. Desired capacity is how many I want it to be normally. I'll put 2 and just put the minimum capacity as 1. Yep. And what else? Yeah, I think that should be all. CPU. Yeah, that's all. I don't want to add anything else. So autoscaling group, add target autoscaling group. Yeah, I think that was all for our autoscaling group. Yeah. So okay, we're gradually coming to the end. So it's deploying right now. The changes that we made are deploying. Oh, now we're over time. I didn't want to go over 2 hours. Just a little moment, we'll be done soon. If you check your AWS console, you'll see all these updates going on in CloudFormation on your stack. Everything you're working on. And the progress, any errors you encounter, and all that. I think that's interesting. Okay, it's done. Let's see if it is recognized by our listener. We have one target group. Aha, so we have 2 targets right now, 2 instances, and both of them have their health checks failed because of access 403. And why would that be? We have our target group. Do we have the access configured? Where's our target group? Seek website target group. Showing access denied. See the permissions. We need to grant permission for that to work. So this is our autoscaling group is in our security. Our autoscaling group is in the security group instance, of course, and the instance SG allows access from the load balancer. Where is the target group? Yeah. Okay. Let's go back to our target group here. One last. So we're going back to the target group in our load balancing here. What's it? Last secret to load balancing. Is it? No. What's this one? Yeah. Cross zone enabled. Our load balancer is configured to use cross zone, I believe, and yes, so we have our targets. We have protocol ports. Just confirming we have all our settings done. Our health check on this part. Yeah, all done. And then our listener and the load balancer is also target group port 80. Let's check that to be sure. We have this configured internet facing true. Okay. Just make it internet facing and have it open. So final configuration. To make it accessible for us, and our load balancer and security group is okay. The load balancer, the listener 80. Sorry, let's add the target with the port. Yeah, I think make the same configuration, a target, and then this should be let's see what we have in our listener. Okay, coming. If this was for we already have the target group attached to our listener here, so we can just add the target to our listener directly here. I think that's what I'm going to do. Attach it to our listener instead of attaching it to our target group. Okay. Yeah, I think this is what we'll do. This should work. Since that other configuration was giving us error. At least we try it out and then we fix it. So we just put our autoscaling group here. And then we should be able to add a port. Or we can leave the default. We can leave the default. Because I see in our listener we already attached the, let me see, what's the problem? Is it too long again? Okay, I will add the pods. Let's see. I'll add the pods. I didn't try to create a new load balancer. I don't know why it did that. So it tried to deploy it and then it rolled back. But I'll just pull it down and redeploy. But I think adding the targets directly to our listener should fix the health check errors that we were getting. Because if our load balancer still sees the health checks as failed, it wouldn't actually route our requests to those instances. So until we fix that and make sure that this unhealthy becomes healthy, it won't be directing any requests to it. That's why I'm like, we have to make sure it goes healthy before it works. These instances, they already exist, they are there in the AWS environment, but we definitely want to make sure that they are healthy. They are healthy behind the scenes, but because of the configuration connecting it with our load balancers, it's not passing the health check that we have configured it to check. And of course, it will not mark it as healthy if it doesn't pass the health check. So that's why I am rechecking it. As you can see, they are running in the environment actually. But I'm redeploying them and would work with that. Okay. But so I'm pulling down and then redeploying the whole thing afresh. I commented out my instance setup so that I'll be using only the Autoscaling group. You can leave yours, but make sure like any changes we're making to the Autoscaling group, you also want to make it to your instance. If it's security group, if it's subnet, if it's anything, because they're similar. That's why I just commented out one so that we can face one. And we should be done very soon. It should have actually been done like 20 minutes ago if our health checks passed in the first trial. But since it didn't, we go through it again and we fix it. Yeah. So going through our code again, what we have our VPC set up. We have our buckets. Currently it's just buckets. And for this bucket to work, we would also need to configure access to the bucket, but we've not yet tried getting anything or putting anything in the bucket. So there's that. And that would be, of course, a resource-based policy that we want to put on the bucket. And load balancer, you have the target group, listener, instance role, you have the instance security group. These are all the different things we have here. We have our auto-scaling group set up. We have, this is adding user data. Then this is adding targets, the format document. Yeah, this is going to take quite some time. But there we have it. Okay. While this goes, we can just check again. This is our S3 storage thing that we were talking about, that we need to grant access and add the files we want to do. But that's long after, like when we're able to use this page, you'll see. It's taken quite some time to do what we wanted to do. Sometimes things get broken like this. I had to pull everything down again because trying to deploy it is seeing that there is a load balancer existing with the same name, and I see that happens because the change I made is trying to redeploy a load balancer, and that usually happens when maybe it wants to replace something. It will deploy a new load balancer and then remove the former one, but because they have the same name, it's going to see that as if it's redeploying it's the same resource twice. A solution could have been to change the name of the load balancer and it would work, but I mean, I feel like some things were already not working well anyway, so we'll just put it down and put it back up again. But let's go check it out. Let's go check it out. And yeah, so this is the website stack. These are the resources that we have. It's quite a lot. We have our website stack, VPC gateway, S3 endpoint, our buckets. So when I say, oh, I'm using the ID name to create the these are the IDs here that you can see for all the resources you created. Website stack hyphen load balancer, website stack hyphen load balancer, SGA, all the things that we're creating. Yeah, there they are. Okay, instance profile role, instance SG. So we have our launch template, and then we have our autoscaling group. Okay, it's terminating this one, shutting down this one. Okay, currently we have 0 instances running. Our autoscaling group is trying to shut down the last instance, and then our delete will be mostly completed. Okay, we don't have any autoscaling group anymore. And that's deleted that. Most of it will be done, so destroyed. And then I can now CDK deploy on Viking. everything, everything. Let's go. Now we have a clean install. Okay, what happened with this? What happened? It says something like, oh, the S3 bucket. The S3 bucket was not deleted. That's why. It says the bucket already existed. So I'm going to delete the stack and then just delete the S3 buckets. Yeah, this one. ACP test bucket 2025, that's what I named it. So I'm deleting it. It needs my confirmation to delete it. Then I will redeploy. Yep. Okay, we go again. CDK deploy. Okay, stuff is going well this time around. Let's see what's going on. So here we can see the creation in progress and the events happening. The same thing is showing in the terminal, is what you can see here actually. And you can see the resources as they are created. If you have any output sets. Yeah. Let's go see what instances we have. These are the instances that we had before. They are terminated. You know the interesting thing? If you select this, there's nothing you can do about it. Like, you can't start it. I mean, you can delete it in code, but it's terminated already. There's nothing you can do about it. It's just there like this history. Let me see which point we are at. We're setting up our VPC right now. I think exactly the same things we set up before. But aside from all the configurations that we've done today with the Autoscaling group and plugging things together with granting access security group or granting access with IAM rule, so far I think it's been a good experience with CDK in these live streams actually, and eventually we would be trying out Terraform. I don't know if you've worked with Terraform before, but it's also an IAC tool. Is it tool? Yeah, it's a tool. Yeah, it's a tool. But it's not built by AWS, and you can use it beyond just AWS. CDK is made for AWS infrastructure, but Terraform has different providers. Like AWS is only one of the providers you use with Terraform. So you can use Terraform to deploy Google Cloud services, Kubernetes services. I mean, so many different providers that you can work with Terraform. So definitely it's something to have in your tool belt or in your arsenal, whichever way you want to refer to it. And we'll be working with Terraform, but we'll be building like 2 more projects with CDK. Like we'll pick 2 workshops from the AWS repository. This is the one we worked with, AWS 101. It's the same one that we did the console, the CLI with, and we'll be picking another one that we would recreate the same way, running into our issues, our errors, and debugging and working through it together. Because I think it's good to actually experience this unfiltered, like natural way of learning also. And we have deployed this stack. Let's see if our health checks are passing. If it's not passing, maybe I'll cry. Okay, we have 2 running. Just check our running. We have 2 running. Our Autoscaling group, because we put desired capacity as 2, you can see here, we have 2 instances to match our desired capacity of 2. That's why this whole Autoscaling thing is really nice. You can put 5 there and it will create 5 instances. And here we are going to check something we want to check, our load balancers. Yeah. So we have this load balancer. The moment of truth is coming. Our listeners. Let's see the target group. We have 2 unhealthy. We're going to have to check what this 2 unhealthy thing is. And I think since we're out of time, I'll check the unhealthy and add it in the recap. But I'm suspecting that it's not checking properly with the health check is meant to get, because instances are running, but the health checks are not checking on the right. Yeah, it's not checking on the right. Let me put this back to 4080, but it's not checking on the right plats, I guess. So I'll just check that one last time, and if we have unhealthy targets, I'm going to do the check outside the call and I'll add it in the recap and give the updates there. But essentially, we've been able to make this work by having everything that we put together here deployed, and as we can see in the console, they are connected the way we want them to be connected, in the right security groups, the right load balancers pointing to the right targets and the right listeners and all that. And our autoscaling group is working as we want it to, deploying 2 instances with our desired capacity of 2. So yeah, I think we have been able to achieve 98% of what we want. The rest would just be fixing the unhealthy target and checking it running. So what you want to do, if this came straight in the healthy, we're going to go to our load balancer, and when we check it, because it's a load balancer that is accessible from the internet, it's a public load balancer essentially. You can see it's internet facing. So you would want to let me just click it so we go to the full page. Yeah. Yep. You want to copy this DNS name, like copy it and go to your browser and just put it there, and it should take you to a page on your it works. Are you kidding me? To take you to a page in your any of your endpoints. It's balancing across multiple instances or whatever you've configured, so it will load that. This is showing us that our load balancer works, but we're supposed to be seeing the page of our server. It's not giving us that because it's saying the what will I call it? It's saying the target is unhealthy right now, so it's not going to direct traffic to it. That's why we're not getting this page that we so want to get. Where is it? It's this page. This is what we're supposed to see. So when we fix the targets, that should be the result. Let me see what the target says. Target groups. No, not balancers. should have, yeah, this target group is unhealthy. This was the previous one that we had. Yeah, so for now it's not directing target to it, but I'm going to fix this and get the updates. But as we can see, our load balancer works, and I think that would be all for tonight. Thank you so much for joining today's session. I hope that you've been able to learn a lot, or even if you were not able to try the things we were trying, you know so much about navigating through the AWS documentation, where to find your answers, what kind of errors you can run into, and the things that you can check with them. Currently, our error is on the health check, and we're going to fix it so that the listeners can see, or rather the target groups, actually it's the target groups, can see the targets as healthy. Right now it sees them as unhealthy, and we can see here it's access denied 403. So we're going to check that and fix that, and see you again next week. Have a nice time. Bye bye.